Hey kids, welcome to section 3.4, solving quadratic equations by factoring. Today I'm going to teach you how to write quadratic equations in standard form and then how you can solve quadratic equations by factoring them. So this page right here has a lot of information on it. Basically, it has why we solve equations by factoring. It also shows you some of the special rules that we talked about in the last section. Basically, the point of solving quadratics by factoring is there's something called the zero product property, which says if you have two things that multiply to give you zero, then one of them has to be equal to zero, or both of them have to be equal to zero. Now, we talked in the last section about how to factor the difference of squares, a squared minus b squared. We talked about how to factor the sum of squares, a squared plus b squared. We also talked about perfect square trinomials and how you can factor those. I also put here in the corner, we learned about how to find intercepts on a graph. And now we're going to discuss the idea that the intercepts are what you get when you factor a quadratic and solve it. We're also going to, at some point, talk about vertex form and how you can use that to graph. Okay, so let's take a look at how you can go backwards. So basically, I'm going to give you the zero of a function, and we're going to write what the equation is. So if this were something from section, say, 3.2, we would have a parabola that is crossing at -5 over here, and a parabola that is crossing like at 3/4 over here. So it's either opening up or it's opening down. The point is these are the roots. So I need to figure out what the f of x equation is that started it all off. So what we're going to do is, since we know they're the roots, then we know that they're x-intercepts. And if they're x-intercepts, that means y equals 0. So I can put these as factors and say x minus 3/4 and x plus 5 equals 0. The reason why I do this is because the factored form, if you remember from the previous slide, had subtraction in it. And so if I know what the intercepts are or the roots are, then I can substitute it in with subtraction. Now, the reason why the second one went to positive is because you have x minus a -5, which is really x plus 5. Well, now to get the quadratic equation in standard form, I need to double distribute. So x times x is x squared. X times 5 is plus 5x. -3/4 times x is -3/4 x. And -3/4 times 5 is -15/4 equals 0. Remember, to multiply fractions, you multiply the tops and you multiply the bottoms. Now, when you write something in standard form, you can't have any fractions. So I'm going to multiply the entire equation by 4 in hopes of eliminating the denominators. So that means everything has to be multiplied by 4. 4 times x squared is 4x squared. 4 times 5x is 20x. 4 times -3/4 is -3x. 4 times -15/4 is -15 equals 0. And now I need to combine like terms in the center. So 4x squared is just hanging out. 20x minus 3x is 17x. And the minus 15 is just hanging out equals 0. This is my quadratic equation in standard form that has the roots 3/4 and -5. So if I were to work backwards and factor, it would give me the problem as the solution. Okay, letter B has roots at -1/3 and 6. So I can say x minus a -1/3 or x plus 1/3, and x minus 6 equals 0. Then I can double distribute. So x times x is x squared. X times -6 is -6x. 1/3 times x is 1/3 x. And 1/3 times -6 is -6/3, which is -2. Again, fractions are not allowed in standard form, so I'm going to multiply the entire equation by 3. So x squared times 3 is 3x squared. Negative 6x times 3 is negative 18x. 1/3 x times 3 is x. Negative 2 times 3 is negative 6 equals 0. Collect your like terms in the middle, so 3x squared minus 17x minus 6 equals 0. All right, so now what we're going to do is we're going to work backwards. I'm going to give you the equation on the bottom, and you're going to have to tell me what the roots are on the top. So we factor. Letter A says to factor out the GCF. So if we look at 20x squared plus 15x equals 0, the GCF is not only an x in common, but a 5. So if I factor a 5x out, I'm left with 5x times 4x is 20x squared, and 5x times a positive 3 gives me 15x. So remember, you should be able to distribute 5x times 4x and get 20x squared, and then 5x times 3 gives you 15x. Now the zero product property says if I have two things, 5x and 4x plus 3, that multiply to give me 0, then one of them has to be 0. So I take and place each of them equal to 0 and solve the mini equations that come out of it. So we have 5x equals 0. Divide both sides by 5. We get x equals 0 is one answer. And 4x plus 3, if I minus 3 to both sides, 4x equals negative 3. Divide by 4. You get x equals a negative 3/4. So there's my two zeros, 0 and negative 3/4. And it's okay that one of them is 0. That happens. The root could go through the origin. It will happen. All right, if we look at letter B, I have a GCF of 2y. So if I have 2y, I need to multiply by 4y squared to get 8y cubed. And then 2y times a negative 1 is 2y. Well, the parenthesis 4y squared minus 1 is the difference of two squares, so I can factor that. Let's see, the square root of 4y squared is 2y and 2y. The square root of 1 is 1 and 1. 1 is positive, 1 is negative. Now I have three things that multiply to give me 0. I can set each of them equal to 0. So 2y equals 0, 2y plus 1 equals 0, and 2y minus 1 equals 0. So this first one, divide everything by 2, I get 0 is my first answer. Subtract 1, 2y equals negative 1, so y equals negative a half. There's my second one. And right here, I add 1, so I get 2y equals 1. Divide by 2, I get y equals a positive 1/2. So if I really wanted to, I could smush these together and say 0 plus or minus a half. All right, if we take a look at letter C, a to the 5th minus 256a equals 0. There's an a in common. That leaves me with a to the 4th minus 256 equals 0. Well, 256 is a perfect square, and so is a to the 4th. So I can do a, and then I can do my two parentheses. And the square root of a to the 4th is a squared. And the square root of 256 is 16. And one's a minus, one's a plus. Now, notice this first parenthesis is still the difference of two squares. So I can leave my a alone, put my two parentheses in, and then leave my a squared plus 16. I cannot factor the sum of two squares. I can only factor the difference of two squares. So if I look at a squared minus 16, the square root of a squared is a and a. The square root of 16 is 4 and 4. I got a minus and a plus. So this gives me a lot of options. The first is a equals 0. Don't have to do any solving there. The second one is a minus 4 equals 0, so that gives me a equals positive 4. The third one is a plus 4 equals 0, so my a equals negative 4. And then my last one, a squared plus 16 equals 0. So move the 16 to the other side. A squared equals negative 16. Square root both sides. A equals plus or minus 4i. So I got 0 plus or minus 4 plus or minus 4i. Okay, if we look at letter D, 7x squared minus 63x equals 0. Well, there's a GCF of 7x. When I factor it out, I'm left with x minus 9 equals 0. Remember, you can check it. 7x times x is 7x squared, and 7x times negative 9 is negative 63x. Now notice x minus 9 looks like the difference of two squares, but it's not because there's no square with the x. So I'm ready to just set them equal to 0. 7x equals 0, x minus 9 equals 0. Divide this by 7, you get 0. Add 9 and you get 9. 0 and 9. All right. This next slide is perfect square trinomials and differences of squares. So if you look at letter A, 4x squared minus 12x plus 9. First, always look to see if there's a GCF. Sometimes there is, sometimes there isn't. Then I'm going to try to factor this. So what I'm going to do is I'm going to guess and check. So the first two things in my parentheses have to multiply to give me the first thing in my problem, 4x squared. I'm going to do 2x and 2x. Then the last things in my parentheses have to multiply to give me the last thing, which is 9. So it's either 3 and 3 or negative 3 and negative 3. Because that middle sign is negative when I collect like terms, then I have negative 3 and negative 3. Again, you can always check your work. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. The inside gives you negative 6x, so that's negative 12x. That works. Negative 3 times negative 3 is 9. Now you set each of these equal to 0. Notice that they're the same, so you really only have to do one of them. Add 3 to both sides. 2x equals 3. Divide by 2, x equals 3 halves. Then if I do the same thing here, you get the same thing. So the answer is x equals 3 halves. Notice it's only one root, which means it either sits on top and opens up or sits on top and opens down. Because it's a positive 4, it opens up. All right, if we take a look at B, 81x squared minus 9x equals 0. Always look for GCF. This one has one at 9x. If I factor out the 9x, I'm left with 9x minus 1, which kind of looks like it's the difference of two squares because 9's a square and 1's a square, but the x is not. So I got two things that multiply to give you 0. You set them each equal to 0. The equation on the left, if I divide both sides by 9, gives me 0. If I add 1 to both sides, I get 1. Divide by 9, I get 1/9. All right, if we take a look at letter C, a squared plus 9 equals 0. Well, I can factor this if I want to, or it's easier if you move the 9 over to the other side. So that becomes a squared equals negative 9. Square root both sides. A equals plus or minus 3i. Now, if you really wanted to, you could factor a squared plus 9 into a plus 3i, a minus 3i. Because it's the sum of two squares, I can do this, but I have to make sure I remember those i's. If I take a look at letter D, 4x squared minus 44x plus 121 equals 0. If I start my two parentheses, the first things in my parentheses have to multiply to give me the first thing. So I have to get 4x squared. So I'm thinking 2x and 2x. The last things in my parentheses have to multiply to give me the last thing, 121. So I'm thinking 11 and 11. Now when they multiply, they get a positive. When they add, they get a negative. That means both of them are negative. So I only have one factor. It appears twice. Set it equal to 0. So 2x minus 11 equals 0. Add the 11 to both sides. 2x equals 11. Divide by 2, x equals 11 halves. Again, that's a quadratic that sits right on the axis. Okay, here's some more factor by solving. You get better at them the more you do. So factoring. So letter A, x squared minus 11x plus 30. If you see three things, no GCF, go right to your two parentheses. Always be looking for that GCF. Okay, so remember, these are the ones where you, the first things in the parentheses have to multiply to give you x squared, so x and x. And then you want to find two numbers that add to give you negative 11 and multiplies to give you 30. So how about negative 6 and negative 5? Those add to give you negative 11, and those multiply to give you 30. Remember, you can always check to see if you factored correctly by double distributing and collecting like terms. You should get back the problem. So when you have two things that multiply to give you 0, you set each of them equal to 0. That's the zero product property. If you solve this equation on the left by adding 6, you get x equals 6. If you solve the equation on the right, you would add 5, so you get x equals 5. Okay, letter B, first thing, look for GCF. Don't see any. Second thing, I have three terms, so I'm going to start two parentheses. The letter in the problem goes at the beginning. Two numbers that add to give me negative 4 and multiply to give me negative 21 would be negative 7 and positive 3. Set each of them equal to 0. X minus 7 equals 0. X plus 3 equals 0. That gives me x equals 7 and x equals negative 3. All right, if we take a look at letter C, 15x squared minus 8x plus 1. Look for a GCF, don't see one. So then I go to my two parentheses because I have three terms. Remember, the first things in the parentheses multiply to give you the first thing. So to get 15x, you could do 5x and 3x. The last things in the parentheses have to multiply to give the last thing 1, so I can only do 1 and 1. Take a look at your signs. When you collect like terms, you get a negative, but when you multiply, you get a positive, so they're both negative. And then always check your work to make sure you factor correctly. So 5x times 3x is 15x squared. 5x times negative 1 is negative 5. 3x times negative 1 is negative 3. Negative 5 and negative 3 is negative 8. Negative 1 times negative 1 is 0. Right? Set each of them equal to 0 and solve. In the equation on the left, if I add 1, I get 5x equals 1, so x equals a fifth. The equation on the right, 3x equals 1, so x equals a third. All right, if we look at letter D, the first thing that pops out at me is the fact that there's a negative in front. That makes factoring fairly difficult, so I'm going to divide everything by negative 1. And that's going to give me 12x squared minus 8x minus 15 equals 0. That's totally allowed because you do it to everything, including the right side of the equation. So then you look for a GCF, don't see one. Count the number of terms, there are 3. So I'm going to try to factor. The first things in the parentheses have to multiply to give you 12. So I'm thinking either 12 and 1, 4 and 3, 6 and 2. I'm going to try 6 and 2. Then I need to find the last things in the parentheses that multiply to give the last thing, negative 15. So that's like -5 and 3. So if I try -5 here and a +3 here, it's called guess and check for a reason. So if I do 6x times 2x, that's 12x squared. 6x times 3 is 18x. -5 times 2x is -10x. -5 times 3 is -15. Okay, notice when I collect like terms, I get 8x, but I want to get -8x. That means my signs are backwards. So I'm going to go ahead and change my signs. And I'll erase this one down here. So I'm going to instead put a -3 and a +5. So you can check it again. You do get -8 this time when you double distribute. Okay, so now set each of them equal to 0. The equation on the left, you can subtract 5, get 6x equals -5. You could divide by 6 and you get x equals -5/6. The equation on the right, you can add 3, so 2x equals 3. Divide by 2, you get x equals 3/2. Again, remember where you started. You started with a quadratic and you ended up with the roots. The very first equation that we did in the beginning, we started with the roots and asked you to find the equation. Okay, now we have a word problem. Juan recorded his brother bungee jumping from a height of 1,100 feet. At the time the cord lifted his brother back up, he was 76 feet above the ground. If Juan started recording as soon as his brother fell, how much time elapsed when the cord snapped back? Use f of x equals -16t squared plus c, where c is the height in feet. Okay, so we have him bungee jumping. Here he is jumping off. Very good. And when he bungee jumps, or when it snaps back, he starts 1,100 feet up, but when he snaps back, he is 76 feet up. So technically, this bungee cord is 1,100 minus 76, or 1,024 feet of cord. So that is the height in feet, which is our c. So I can use the equation f of t equals -16t squared plus 1,024. Okay, I want the cord snapping back and I want him coming back. So that's when I would set this equal to 0. Now I need to solve for t, so I need to get the t by itself. I'm going to move the 16t to the left by adding, just so it makes it positive. So 16t squared equals 1,024. I can divide by 16. That gives me t squared equals 64. I can square root both sides. That gives me plus or minus 8, except I can't have negative time, so 8 seconds. So it takes 8 seconds for Juan to snap back. Okay, second example, the height of a javelin is in feet is modeled by h of t equals -16t squared plus 79t plus 5, where t is the time in seconds after the javelin is thrown. How long is it in the air? Well, remember, when anything is thrown or kicked, it follows a parabolic path. Remember, this 16 is for gravity. This 79 is your initial velocity. And the 5 is how far off the ground you are. So if I want the javelin hitting the ground, then I want the equation equal to 0. Now, to solve for t, first, I don't like this negative in front, so I'm going to divide everything by -1. So that gives me 16t squared minus 79t minus 5. Now I look and see if there's a GCF. There is not. I count the number of terms. There are 3. So I'm going to jump to my 2 parentheses. And so we're going to guess and check. Let's see, the first things in my parentheses have to multiply to give me 16t squared. So I don't know, maybe 4t and 4t. The last things in my parentheses are going to multiply to give me negative 5. So that's like 5 and 1. And one's got to be negative and one's going to be positive. So I guess 4t plus 1 and 4t minus 5. But if I distribute, I get 4t times 4t. That is 16t squared. But then I get negative 20t plus 4t. That's only negative 16t. I need negative 79t, which means my 4s are not right, and I need to fix those. So let's try. Let's see what else multiplies. Give me 16. How about 8 and 2? So now when I distribute, I get 16t squared. I get negative 40t plus 2. Well, that's negative 38, which is not negative 79. And if I swapped the 5 and the 1, I would still only get 2. So that's not going to work. So maybe we try one more time. That's why this is called guess and check. Let's try 16 and 1. Ooh, this looks better. So now if I double distribute, I get negative 80t on the outside and 1t on the inside. So negative 80 and 1 is negative 79. Yay, we did it. So now we can take each parenthesis and set it equal to 0. Okay, the one on the left, I'm going to minus 1 to both sides. So 16t equals negative 1. Divide by 16, t equals negative 1/16. Well, that doesn't make any sense because time has to be positive, so we're going to forget about that one. If I add 5 to both sides, I get t equals 5. Ooh, that's positive. 5 seconds. All right, if you guys have any questions, please let me know. And as always, keep calm and keep trucking.